The purpose of any program or a simple application or a big or complex application is just processing some data. In this program, we just processing this hello world message by using this printf. Namely, we are printing this message to the main screen just like this. In other words, we just process this data. Therefore, whether it is a simple program or a big or complex application, we always processing some kinds of data. Therefore, it is very important to know data types in a language, including C. In this section, we are going to introduce basic data types in C. First, in the following section, I will create a folder and then we will continue to introduce the basic data types. Let's open this folder first, then add a file. Okay, I just paste this code because I just use this. First, just I comment this. This is the comment in C. We have used two types of comment. This is the first one. This is the new one actually. The second one is just like this. Therefore, we may for one line comment we use this one. For multiple line comments we may use this one. Okay, now let's see the data types. Actually, in C, there are mainly 5 basic data types. The basic data types are char, character, int, integer, float, single precision, floating point numbers, and double precision, floating point numbers. Void, no size or range, just indicate the absence of a value. These are the basic data types in C. Of course, there are other data types, but they are the derived data types. Later, we will introduce it and we will learn it and we will use it. In the following section, let's see one by one. First, let's see this char data type. Char. In C, the char data type is used to store single character. Actually, it occupies 1 byte of memory and its value ranges from -128 to +127 for signed char, and from 0 to 255 for unsigned char. Namely, this char data type has 2 kinds of ranges. The one is in the signed data type range. The second one is unsigned data type range. First, I just declared this letter variable and then assign it a single letter, because in char data type we can store a single character. This is the single character. Then I also declared another variable, namely digit. Then I have assigned an integer digit, for example 5, to this digit variable. Finally, I just declared a special symbol, okay, special symbol, this variable, and then assign it to the $mark. Namely, in this data type char, we can store single character, we can also store digits, we can also store special symbols. Okay, now, how we can print it? Last time we just print the hello world. This time we have this new data type. The first time we just mentioned about data type, and we are going to print data type, for example, char, character. Therefore, in this case, we also just write here, for example, we are going to print A, then print 5, and then let's print the symbol. Namely, we are going to print letter colon A, then digit colon 5, then spatial symbol colon this dollar mark. Okay, let's do that. Therefore, letter colon, then we need have format. Later I will see that %C. Actually, this %C, this is the character and this is the format. Namely, in order to print the char variables, we need this format. Then here put the actual this variable, namely this letter. Okay, now this will print this A to the standard output. Namely, we have format here. This is very important because %char, this is a format for characters, single characters. Therefore, we need to use this. Then in the second line, we are going to print this digit 5. Then in the third line, we are going to print this dollar mark. Therefore, after print this, we need to go to the second line, start of the second line. Therefore, we have here this \n. Actually, this \n is represent the new line. First, it's print this content of this variable, namely A, then it's go to the new line. Okay, so I just copy this, then paste it here, then we change it to digit, then we also change it here digit. Okay, then we are going to print this one. Okay, I just copy it, spatial symbol. Okay, therefore I just copy this and replace this with one. Okay, now actually our print statement is completed. Okay, now in order to print this, I repeat again, and we use this format. This is the format, printing format for character data type. Therefore, because all variables are character type, therefore we just using this format of character type, namely %C. Okay, now let's run this code and see the result. Hopefully we are going to print a first line, in the second line 5, in the third line this dollar mark. Okay, now let's do that. Okay, here we go. The first line is A, the second line is 5, the third line is this dollar mark. Let's see here. First, we have letter, then semicolon, and then we have this. Just here, the value of the variable will be print just here after this. This is the position of print, or this is the, in other words, this is the format and the position of the this values printing position. Okay, now this is good, and we just saw that our char data type, first data type. Now let's see the second data type, int. Okay, now let's see the integer data type. Okay, I remove here and also just remove here. Okay, let me write here. The second one is int. Now first I am going to declare the variable. For example, int. Okay, let's say number 1 is 100, for example. Then int num2, assign it -200. Then let's say the sum, num1 plus num2. Okay. Okay. Now, first variable is number 1, 100. We assign it 100. The second variable is num2. We just assign it minus 200. Then third variable is sum. Summary. We are going to sum the first number and the second number. And then that sum will be the total will be assigned to this sum. Now let's print this value. Let's say first number, then format. In the case of int, we have different format. Namely, we have %d. Okay, therefore this is the format for integer numbers. Okay, therefore just like the before that, because we are going to print the first number, then we are going to print the second number in the second line, then we are going to print the sum in the third line. Therefore we need that new line, namely \n. Then we are going to put here the variable just like the previous one. Number 1, for example, number 1, this is the good. Now we completed the first line. In the second line, we are going to print the second number. Therefore, I just copy and paste these statements and change corresponding on the second. Okay, second number, I just change it here to, then the sum. Let's sum here. Okay, then the sum also is digit or integer, therefore we use this format as well. And then here is, because we just put the sum, because we have variable here, this is the variable. Now I have completed the code. In summary, what I have done until now is, first I just declared 3 variables. The first one is number 1, I just assigned 100. The second is also int, assigned minus 200. The third one is the sum, and this is also int. Therefore, first I just declared the variables by using this integer data type. Then now I am printing it here. The first number is going to print is, the format is different. The format this time is %d. Namely, this is the format for printing integers. And then this is also integer, same thing. This is some also integer. Therefore, we are using the same format here. Now, our simple code, namely printing integer number to the standard output in 3 lines, is completed. Now let's run the code and see result. Okay, here we go. The first number is 100, the second number is minus 200, and then the sum is minus 100. Let's see the property of integer number. For example, int data type typically occupies 4 bytes of memory, and its range is typically very big. For example, I just write here size is 4 bytes in memory. Okay, it occupies 4 bytes in the memory. The first thing. The second, its range. The range is very big. Actually, it represents from minus to 147, 483, 648 to this number. The range is very big. Therefore, int is used for whole numbers. Arithmetic operations like addition, subtraction, multiplication, etc. can be performed on its value. And D is used for printing the int data type. I just removed this. Okay, now also remove this one. The third one is float. This is single precision floating point data, namely decimal values. Decimal values. In order to represent decimal values, we are using this float data type. In terms of size, it occupies 4 bytes of memory. Okay, just same as int, but this is decimal. Now let's see one simple example. First, okay, float. This is a float data type. For example, a distance. Let's say distance, and then for example, 1, 2, 3, 4, f. When we declare float data type, we always use this f. If we don't use f, later we will say it will represent double. Double and the float is both represent decimal values, but for lower precision, namely single precision, we are using float. For double precision, we are using double. For example, float, let's say speed, we just have distance and divide by, actually here semicolon. Okay, first we have distance, and then we have time, and then we have speed. Actually, we know that from physics, and the distance divided by time gives us the speed, and therefore in both cases this is float, because we are just representing this distance with float f, and this is floating point number, and the time is also floating point number. Of course, the result, namely the speed, also a floating point number. Now let's print that. We print it in the char, we also print in the int, but we are also printing is a floating point, because why we print in the time is because in each case the format is different. Therefore I am going to show the printf with different formats, basically format for char, format for integer, and the format for single precision floating point. Therefore first let's printf, and okay, now distance. Okay, now in the case of floating point, we use different format, namely we use f. Actually, percentage f is the format for single precision floating point numbers. Now let's see here, in the first number we have 2 digits after this decimal point. In the second number we have 1 digit. This is different. Therefore in the printf we need to mention this. Here we just add 2. Now we are going to print this number just after this decimal point. We have 2 places, 2 digits. Then, okay, we are going to print it in the new line. Therefore, we just add this, then distance. Okay, now I just add one comment here. Okay, actually this percentage dot to f limits the output to 2 decimal places. If we are going to do 1 decimal place at that time, this should be 1. Then I just copy this, let's do this, change this, it's quick. This is the time. Okay, here is also time. Okay, but in the case of time, we have 1 digits after the decimal point. Therefore, this should be 1. Then this is the speed. Okay, let's in the speed let's use 2. Okay, then this is the speed as well. Now I have completed this code. In summary, the float data type, namely single precision floating point number type, occupies 4 bytes of memory. And then when we print it, we have different format. Namely, we have used this f, percentage, and f, but we have also determined how many digits after the decimal point. Therefore, here we add them 2 and 1 and 2. This represents the digits after the decimal point. Namely, I just read a comment here, limits the output to two decimal places. Okay, now our code is completed. So run this. Hopefully in the first line we are going to see this number, and in the second line we just see 2.5, and in the third line we are going to see the calculated the speed. Okay, let's run the code and see the result. Okay, now distance is 123.45. This is the time 2.5, and this is the calculated speed. Later we will also see the range of this floating point data type. Now let's see double data type. This is also decimal values, but high precision. Just change this. Okay, double. Let's change this double and change also double. At that time, we just remove this one. In the case of double data type, we also use this F, percentage F, because this is high precision. Okay, let's do this 15 here, and let's do this also here 9 something, and let's do it here 6, for example. Let's see the result, the same result. Now I just remove this comment. Okay, now we just changed this double. The value is the same, but let's see, when we print this, we are printing 15 digits after the decimal point. In this case, we are printing 6 decimal points. Actually, we have two, we have one here, but let's see it in the print. And then the speed, we are seeing this one, 9, for example. Okay, so now let's run this and see the result. Okay, so therefore, the distance, okay, this distance, for example, 123.45, float with 0. Both float and double are used to represent decimal values, but a float used to single precision, and a double is used to double or higher precision number. When we declare it, in the case of float, and we just put F in the end of data. That's the difference. Void data type is represent nothing. It represents absence of value. Later we will see this is basically used to return type of function. Namely, if a function should not return nothing at that time, the data type is void. We will see this in later courses when we talk about the functions. In this section, we just explained 5 basic data types. Actually, there are other data types as well. All of these data types are derived data types. In summary, in the section, we just learned about the data types. This is a table, just summary of data types, size, and the limits. This column is represent data type, this column represents the sizes, and this is the range, signed range, and this is the unsigned range. We just saw that. This first data type, we just saw that the character data type, and its size is 1 byte. And we just saw that its range is, it has 2 range. One is signed range and another one is unsigned range. In the case of signed range, it represents from -128 to 127. In the case of unsigned range, it represents from 0 to 255. Then, in the case of int, it occupies 4 bytes memory. Then, this is the signed range from minus this number to this number, very big number, and then this is the range in unsigned. The next data type is float. We just saw that the float is occupies 4 byte memory, and then actually its signed range is from minus to this number 3.4. Its exponential 38. This is very big number, and this is very small number. From very small number to very big number, actually, you see here, 38 exponential. Then we don't have, in this case, we don't have unsigned range, and then this is double. This is also very big, most big. We have here exponential 308 from minus to plus. This is very big number. We also saw void, because void represents the absence of value, therefore I didn't mention it here. Then we have short and the long numbers. The short is actually, this is also number, but it represents the 16-bit data. Actually, this occupies 2 bytes or 16-bit. This is the signed range, and this is the unsigned range. Then we have long. Sometimes we use this in the case of 32-bit, and it occupies 4 bytes of memory, or in some computer it might be occupy 8 bytes of memory. And this is the signed range from this minus from this number to this number, and this is the unsigned range. We have derived types. We just mentioned that in the previous section. We have basic data types, namely character, integer, float, double, and void. Then we have derived data types. What is derived data types? Because we have basic data types. These data types is derived from that basic data types. For example, array, items of same type. For example, items of int, items of character, or items of float, or items of double, namely array. This array is a data type, but it's derived data type. Then we have a pointer. This pointer actually address of another variable. We just saw that variable, for example, speed. We just saw that the variable distance. We just saw the variable time. That's the variable. Then in the later we will learn that in C we have pointer. The pointer actually is address of another variable. The pointer is variable, but it's address of another variable, namely its address of memory. In the computer, every memory has some kind of location or position. Therefore, the pointer is just address of some kind of variable. Then we have function return types. We just saw that void, or some function don't return anything. Basically return void, nothing. Some function returns int. For example, we just saw that in the code we have main function. The main function is always returning integer values. Therefore, the return type is also a data type. Then we have structure. It's a group variable of different types. Therefore, actually, this structure is also derived data types. We also have user-defined data types. For example, sometimes we can define structure, user-defined structures, namely combine variables of different data types. For example, if we have a structure, inside the structure we have int, char, or float, or double, something like that. Then we have union. Actually, this union is also user-defined data types. In the case of union, we will later learn what is union. But here, just mention that it's user. We have user-defined data types. For example, all members share the same memory location. Enumeration. Actually, this is also data types that consist of integral constants. Therefore, in summary, we have basic data types: character, integer, float, and double and void. And then we have derived data types, array, structure, something. And then finally we have also user-defined data types. Therefore, data types in C is very important. until here, we just learned that basic data types. We didn't learn this yet. We will learn these derived data types. We also learn these user-defined data types in later. In this course, we just used variable, double, distance, and the time, and the speed. And previously, we also used this kind of examples. For example, in the case of char, and we just use it letter, digit, spatial symbols. And in the case of init, we also use number 1, number 2, and the sum. In the case of float, we use distance, time, speed. In the case of this double, we also use the same distance and time and speed. We call these variables or identifier. Okay, if I use this here, char, I didn't change anything. This is double, and the variable name is I just changed char. Actually, we know that char is a data type. But here, I use char as a variable, and then it shows me error. For example, if I run this, and it shows error. It says here, error. And this line, this char, error is here. Namely, I couldn't use this char instead of that distance. We just use here distance, and here, if I here use int, for example, int, it's also error. Because actually in C, we have some words, reserved words. We can't use that words as variable name. I just use a char, it shows error. I just used in here instead of time, I used in, it shows error. Because in C, we have reserved words. They are auto, break, case, char, constant, continue, default, do, double, else, enum, extend. You see written here. We have written. We have short here, signed here, size of static, and struct, switch type, union, unsigned, void. We have void here as well. And we have while here. Namely, these words can't be used as variable name in C. Therefore, we call this reserved words in C. Therefore, when you use variable name, you need to remember this. Of course, if you don't remember it, and when you use it as a variable name, at a time the C compiler shows you error, it's okay. But we need to remember that they are reserved words in C, they are this one. In this lecture, we have explained, we have introduced basic data types in C, namely character, int, float, double, void. And then we also give examples, and we also explain the formats for each data type. Then, when we declare floating point number, float, then in the end of number, we just add them, f. We also saw the data type size and the limits. We also introduced derived data types, and basically they are array, pointer, function, and the structure. Then we also introduced user-defined data types, struct, union, enumeration. And finally, we have introduced reserved keywords or reserved words in C. Thank you for your watching. If you enjoyed this course, please subscribe and please give a like.